Hello, my dear students. So we are approaching the final. Hope you guys are the best. And let's go through the revision. Now you guys will have the stoichiometry. In stoichiometry, you need to know how to calculate the molecular masses of any compound. Okay? So in here we have sucrose, and sucrose has 12 carbons, 22 hydrogens and 11 oxygens, and what they do is that they multiply each by the molar masses and they add them up, and you get the molar mass of sucrose, which will be for 1 mole, right? Okay, and then you need to be able to find the molar masses. We might ask you some logical questions regarding the molar masses, so please practice this and you're going to be able to get it. You're going to use the periodic table to find the molar masses. For example, magnesium is 24, nitrogen is 14, and oxygen is 16. So you got 14 plus 3 times 16 times 2 plus 24. So this should give you the answer. Okay, and then we're gonna practice about the liters, how many liters are coming out. So how many liters of hydrogen will be produced from 6.2 moles of water? You need to write your reaction, you need to balance it, and once you balance, you set up your proportion, or you can use the mole amount, it's up to you, and you can get your liters in here. Most of you got this. I don't think you have any problems with that, but please make sure you go through this. And this is the easy question. So if you got 64 grams of something, how many moles is that? You just need to divide it by the molar mass of hydrogen, which is 2 grams. 64 divided by 2. So gram divided by gram per mole will give you the mole amount of 32 moles. And you will find the number of molecules. You need to use Avogadro number. And liters, you will know that for 1 mole it is 22.4 liter gas at STP. Okay, at room temperature it is room temperature and pressure, it is 24 liters per mole. Now you might really review this like 2 reactions. So when you have 2 reactions on a row, and if we ask you a mole of the last one from here, you need to do a calculation for this one, and then you need to do a calculation for this one, because as you see, we have in here ethine that is made as a product, is used as a reactant in the second reaction. So you need to first of all find out how many moles. Let's say 2 moles are made in here. That 2 moles will be used in here to make this guy, right? So you need to do your double reactions and be able to go from back towards the front, or from front towards the back. Okay, figuring out the mole amount, and then you need to for sure learn how to balance. By this point, I believe you guys all got it. I would recommend to go through this list and try to balance to see if it's matching or not. So these are the alcohols we have. So we have reactions, combustion reaction, which produces carbon dioxide and water. So you need to write this reaction and then balance it. And from here you will use stoichiometry to figure out how many grams or how many liters of what we need to get. That is that regarding the stoichiometry. Now about the thermochemistry. Thermochemistry, you need to know what kind of process all these are. If it's exothermic, endothermic, you need to go through this. The reactions where the Q is written on the product means that it is exothermic. If it's negative Q or plus Q on the left side, it means it is endothermic. So please go through this. You know that delta H equals to negative Q, and it is always like that. So When you have your Q positive, that means your delta H would be negative. Okay, so it works like that. Now enthalpy change, you know the equation delta H equals to negative Q, which equals to negative MC delta T, and delta T means T final minus T initial. You need to know this stuff. And regarding potential energy and reaction pathway, as you see, when your potential energy drops like this, you have exothermic reaction, because this side minus this side will give you a delta H of negative value. And we know that for exothermic we have the Q positive, and it is the exact opposite for the endothermic ones. Now please go through this questions again. When you have 1.15 gram sample, it thrown into 20 grams of water, and there was this much temperature increase. Some of you guys were saying that, okay, if delta T is 3.8 Kelvin, so delta in terms of Celsius, they would when, let's say, they would have 3.80 Celsius. For delta T, they would add 3.80 plus 273. Okay, this is wrong, guys. This is wrong. Okay, the delta T is gonna be the same. Okay, so if delta T is 3.8 Celsius, it is the same as 3.80 Kelvin. Okay, it is the same. Please do not change and add 273 or something like that. You need to put your specific heat capacity, you need to put your delta T, and you need to put the mass of the solution. You will get the Q, okay? And then from there, we're asking you calculate the enthalpy change. So whenever we ask you enthalpy change, most of the time we're going to ask you for 1 mole, okay? 1 mole of solution. If we told you that we use 1.15 gram, then you need to find this delta H for 1 mole, okay? Always find it for the 1 mole. What is the molar mass of lithium chloride? It is 42.4. So you found in here that 1.15 gram gives 0.397 kilojoule, and then you know that 42.4 gram will give X kilojoule, and you would do your cross multiplication and get your answer for delta H, okay? Delta H for 1 mole. So please perform that and do this equation too, because we did this in our test, in our thermochemistry test. I've done a video about it. And Kamran Malim also did the solution of the test 3. So you guys have a lot of sources. I would recommend to go through the test 3 solution with the one Kamran Malim did, and also go through the final review questions in here. So calculate the amount of energy released when 92 grams of ethanol is used. Okay, so figure this out and write it. Specifically this question, please go through here. He says that calculate the molar enthalpy of neutralization of hydrochloric acid, meaning for 1 mole of hydrochloric acid, what was the delta H, okay? But you need to write the reaction. Hydrochloric acid plus sodium hydroxide gives you neutralization reaction, sodium chloride and the water. And then you will write everything in here, MC delta T, okay? In the laboratory, we did this experiment, and I've done the solution of this too. So go through the question in the thermochemistry for this one too. Now, chemical kinetics. Chemical kinetics, a lot of you were confused. So let's say I have a graph in here like that, right? This is volume of hydrogen released per time, right? This is the way I measure the rate of reaction. if I ask you to find the average rate of reaction, the only thing that you need to do is that you see the point where it gets like stable in here. Like it's kind of stable, right? Just before that, right here, this is gonna be, just mark this down, and you would see that the delta V, like this part, divided by this much time is gonna give you the average rate. So you got here about 40, and then you have 5 minutes. So 40 divided by 5, it would be 8 centimeter cube per minute. That is gonna be your average rate of reaction. If I ask you the rate at minute 2 specifically, this is instantaneous rate, you're gonna draw a line in here. Sorry. You're gonna draw a line in here, and then you're gonna try to find the slope of this. What you will do is that either locate 2 points, and this is gonna be x2, y2, this is gonna be x1, y1, and you can do delta y over delta x and find the slope, okay? Which will give you the rate of reaction at minute t 2 minutes, okay? Or you can just like grab this and grab this. This is your delta y and this is your delta x. Just divide this space. You see in here how many boxes, mathematical boxes we have. So grab this much space, this height divided by this height will give you the rate at minute 2. Now, initial rate, you need to draw the line and make it closer to the curve, okay? This is your rate at initial rate. This is initial rate. Now, regarding the graphs that are giving you faster speed, I'm going to talk about that. But you know the collision theory. Collision theory states that for particles to react, they must have minimum amount of energy, meaning that there's going to be activation energy, and there's got to be a correct orientation. Also, the stuff that is affecting the rate of reaction, the factors. One of them was concentration, the other one is pressure, surface area, temperature, catalysis. All of them are influencing the rate of reaction positively, meaning if you increase any one of them, it will speed up the rate of reaction. We have done the very thorough explanation on this. You need to know, for example, from here, what is A? From here, we know that A is what? We have done this, it's called activated complex. B in here is your activation energy. Activation energy of forward reaction. Okay? Forward reaction. C in here is activation energy, EA, for reverse reaction. Reverse reaction. You know, the reaction might go from forward to backwards. We have discussed it with you. And D is, we have done it with you guys in the class as well. I have mapped it out, so please go through your notes. This is the question that we had in your exam for test 3. For example, from here, as you see, we got the dotted line, right? This is the dotted line that we have. Let's compare the rates of different cases. As you see, A and B case have a smaller slope. Means that A and B are slow. slower than the dotted line. But as you see, C and D have higher slope, meaning C and D are faster than dotted line. You need to recognize this, okay? Higher slope, so this one K1, K2, K3. So K1 is faster than K2 and K3, like this, if this is your graph. Okay, so in here, put them in increasing order, so you can put that in the increasing order yourself. Now, in here, if I have this given condition, I change the question. I'm asking here, case A, concentration of hydrochloric acid doubled. Would it increase the rate of reaction or not? We know that it will, because the concentration affects positively. Temperature, does it increase or not? Of course it does. Pressure of the system and temperature of the system are increased. They are both positively influencing, so the rate of reaction will go higher in all three. Now, pressure of the system increased while temperature is decreased. Okay, so this one is increasing while this one is decreasing. Do we know that final rate of reaction will increase or not? We don't have enough information. We don't know. We do not have enough info to decide. More investigation is needed. Now, at room temperature, we did this again. So what you needed to do is draw this graph. You would have done it here, and then you would find the average rate, which means you would divide this distance by this. Kamran Mallim has went through this, so please watch the video. Acids and bases, I'm just going to quickly go over the stuff that you need to know. Acids, you need to know their property. They are soluble in water, corrosive. And what corrosive means, it can hurt your skin. Acids, what color they give the purple color. They turn the litmus red. They come monoprotic, diprotic, triprotic. As you see, we have hydrochloric acid here, H2SO4, which is diprotic, and H3PO4. This is your triprotic acid. Now in here, let's look at this. I've got H2CO3 with OH as a product. Look what I'm getting. I'm getting HCO3 negative and water. It means that this OH took the hydrogen from this guy, right? So here I know that OH is acting like a base, and this is acting like an acid. Well, if I go back to this reaction, you see it's going backwards and front, like meaning that reaction can go backwards and forward. Now, when I look back into this side, I see that in this case, water is giving the hydrogen because HCO3 negative is taking the hydrogen from water and getting back into this shape, right? So that's why this is acting like an acid and this is acting like a base. And when you construct the conjugate acid and base, you can see it clearly. So this conjugate base and this is the conjugate acid. They are conjugates with each other. And this is the conjugate acid, conjugate base with this guy. Okay? You need to mark your conjugates very clearly. Now, the difference between the strong and weak acids. Strong acids, I told you, it ionizes fully, okay? But the weak ones, they do not ionize fully. Some of it is left like this. So the more ions you have, the better conduction you have, the conductivity. Now, we have indicators to tell us the same thing happens with the bases, okay? Bases. When they, for example, potassium hydroxide, it goes fully OH negative and potassium plus, which is why potassium hydroxide is a strong base, okay? If it would not dissociate fully, it's not a strong base. Now, the higher the concentration of hydrogen ions, the lower the pH. We're going to talk about that. Now, indicators. indicators, we had the litmus, phenolphthalein, methyl orange. You guys need to know what each one gives in different type of solution. Phenolphthalein, this is a pink. This is the titration that I did in the lab. Methyl orange, if you guys remember, we did this when I dropped it on your solutions. And litmus red and blue, we did the test with you guys in the lab as well. Now the pH scale. We know that the 14 is the highest, 0 is the lowest, 7 is the neutral. Now this side is acidic, and this side is basic or alkaline. The lower the value, the stronger the acid is. As you see, these are the low values, right? These are strong acids. And they have a higher conductivity because they have lots of ions, lots of ions. While weak acids, they have slightly higher, actually they could have a little pretty high pH levels, but less than 7. And that's why their conductivity is low, because they do not fully ionize, okay? They do not fully ionize, while strong acids fully ionize. Now, properties of bases. Bases will have a higher pH, the strong ones, and ammonia solution is the weak one. As you see, the weaker ones has a lower value, closer to acids, and which is why the conductivity is lower, while the strong ones have a higher pH and higher conductivity value. Now, reactions of acids and bases. You guys need to know this by heart. Acid and a metal give salt and hydrogen gas. Acid and a base give salt and water. And reaction of bases, you need to know this by heart. Sodium, calcium hydroxide, all of this stuff, okay? Acid plus metal, what it gives, so there's an example. Acid plus base, okay? Acid plus base, an example. And there's also oxide, basic oxide, what it gives as a product. As you see, salt and water, it's the same thing. Acid plus carbonate, a metal carbonate. As you see, we get the salt, we get the water, and CO2. Now, reactions of the bases, base plus acid gives salt and water. In here, you have calcium hydroxide plus a salt. This is an interesting reaction. So as you see, we get the salt again, we get the water, and we get our base back. Okay, so please go through this reaction. Remember to check out the names, because we're going to give you the names of the acids, and we will expect you to write the structure. Write the formula. And then write the symbol equations. So zinc metal reacts with hydrochloric acid. We will expect you to write your reactions. This is the product. So chlor 2 plus H2, and we expect you to balance it. Once you do this, you can perform your stoichiometry or thermochemical calculations. Iron hydroxide, sulfuric acid. So we have done this many times. I have written it. Please check your notebooks and you would see the reaction product. I know that iron is 3 valency, hydroxide is 1 valency, that's why 3 comes here. SO4 is 2 and hydrogen is 1, that's why it'll be SO4, and this gonna be 3 and 2, like this, and you will get a water. So a base plus acid gives you salt and water. Now you need to do this on your own, because Kamran Mallim has done it in the video too. Please go through the solutions. The same thing with this one, and I think you guys would be fine. You should be okay for the exam. So make sure to go through the revision notes and watch the Kamran Mallim's video. I hope you guys, good luck, you're the best. Take care.